excited to bring Ajay Kapur on the stage. He will be telling us about how technology and culture tells stories through live performances and more about his company. So please help me welcome him on the stage.
Welcome, everyone. So, as you can probably tell, I'm Indian. And when I told my parents that I wanted to be an artist, they were like, so you have a choice. You can be a doctor or you can be an engineer. And when I was like, no, I actually really want to be a musician, they were like, okay, that's fine as long as you learn how to program and do computer science, which at the time I really didn't understand, but now I actually see that being an engineer is actually a big part of my artwork and who I am and how I express myself artistically. So I ended up actually going to Princeton and meeting a professor who taught me both music and computer science. I've also been mentored by many different artists. I went and did a doctorate where I actually had an interdisciplinary experience where I studied with computer scientist, electrical engineer, musician, a psychologist, and a mechanical engineer. And at the same time, I was balancing my life by studying with artists, learning about interaction design, going and working with robotic artists, and studying a lot of Indian classical music. So as I unveil part of my story, you'll see that I needed all of this type of education in order to move forward with my artistic pursuit. So today I'm going to talk about that, but I'm also going to talk about the educational process of creating the modern artist, and really leading by example of my story, but how I'm working with amazing students at the university I work at California Institute of the Arts, and how we're moving forward in teaching this practice. And I want to talk about a really beautiful Sanskrit word called gharana. Okay, and it's really interesting because it's really means lineage of apprenticeship. When I started studying sitar, I would go to my teacher's house, and it was a very simple house, and they would have this incredible family tree behind them showing where all the knowledge over the years has come from. And often you're seeing the student, and you're seeing the brothers and sisters of students together and where they learn from and how compositions were getting passed from person to person, even marriages where people were coming and bringing compositions together. This is actually amazing because this has, in my opinion, some of the best sitar players in the world. And what's amazing is you trace it back to the 1700s, they all came from the same place. Which is super amazing and beautiful. And I think in this time of digital art, I think we have to start thinking and looking at that, because if we start seeing that process, we'll respect the knowledge of where it's coming from and how we're pushing it forward. So I kind of started this idea of looking at one of my main teachers, Perry Cook, at Princeton, and I interviewed him and I said, okay, where did you learn from? And often in this era, we're seeing a lot of people coming from university. In computer music, Stanford University played a huge role in that. And I interviewed them and found that at some point, John Chowning, who's the inventor of FM synth, by the way, his teacher was Max Matthews. And if you look at the computer music world right now, all around the world, we can all trace ourselves back to that man in one way or another in the pedagogical aspect of what's going on. So it's very beautiful. Again, it's not the 1700s, that's, 1950s, and it's a very new field of what's going on. And I went and then asked Perry, okay, so who are the teachers or your students, and what's your Gharana? What have you taught? And what's amazing is if you look at him and the people I studied with, we're actually professors all around the world teaching this skill and teaching digital art and teaching digital music. And now I've been teaching for 10 years. and I started to look at myself, and I realized that I myself have a particular way in which I teach, and different sets of students who are now also becoming professors all around the world, and also being absorbed in Silicon Valley and being absorbed in LA in a lot of the creative industry. And I believe there's a process that we're using to generate these type of thinkers. And that's really what I want to share with you today, while also revealing some of my work. So in the Gharana that we're teaching, it's very interesting because it's probably not what you would expect from an arts education. And I'm going to go through all this, but the idea of learning how to code, the idea of learning electronics, the idea of learning mechatronics, the idea of making shows, and something that is a very important part of the future that we're still just tapping into, which is machine learning and AI. And as we get more and more digital, artists are going to rely on those type of tools. And at the end of this talk, I'll show you some of the things we've been doing in that space. My personal work has been about being a human musician on stage with a musical instrument, building a neural network that understands what I'm doing, and then building mechatronic systems so that I can communicate with them and actually perform with them. And I'll show you that journey, and again, show you how, more importantly, I'm creating a set of students who can go out in the world and do these type of things. So text-based coding is super important, and in the age of digital art, it's really important because if you teach an artist how to code, you are now teaching an artist how to control the machine. Without the ability to code, they're reliant on the corporations, big or small, to determine what they can do with their computers. So this is a very important part of our process. And I've been working with a language which was invented by one of my people in my Gharana, Ga Wang from Stanford University. And actually, 4 of us have been going around the world spreading this language. It's a language that teaches you C or C++. It's not really C or C++, but it has all the principles. And the idea is you take it and you're able to code. And what we usually do is you're teaching music and making music compositions, but you're actually teaching the cores of computer science. So here's a piece of code that a student has written, and this is the audio and sound that came out. So this is like a 4th week assignment. How many people have studied coding before? Okay, so probably a way better introduction to computer science than sorting algorithms. Please kill me. We actually believe in this so much that it has now become part of our recruiting process, where we're looking for artists around the world who want to code, or maybe it's not in their high schools, so we'll give it to you. So we have this class online where students can come, and we're actually finding more and more that our students are taking these courses online and applying with coding and these ideas in their portfolio. So we're getting the right type of student on campus, and we can push them forward, which is a really important part of building the Gharana, while also giving certification to people that they can do this and move it forward. So once you learn how to code, we actually want to teach you how to now not touch your computer, which is what I'm doing right now. It's like, how do you build like interfaces like this, but that are artistic, and you can perform and be with the audience and be able to interact with the machine, or interact with the artwork, or interact with yourself, or whatever it is you're doing. So over the years, I've been working with students to build new instruments that they want to use as artists. And I think there's around 50 here. I think there's been actually close to 100 that have been built successfully and that students have used in performances, some who have gone and toured with these new instruments and have become a huge part of their professional practice, and others that have gone into gallery spaces and pushed this forward. And this is a really important part, because now you're teaching artists how to make microchips, how to etch, how to build their own circuit boards, how to use sensors to have the audience interact with what they're doing, let alone themselves interact with their own instruments that they're making. So leading by example, I'll show you some of the instruments I've been making over the years. So I started, my first project was in 2002, building a digital Indian drum called the e-tabla, and then the e-dholak, and then the e-sitar. And I'll show you a little of those. Next was like a multi-touch or a multi-person playing networked instrument. So this was a networked concert between Canada and the US where we're playing this modified instrument. And then this is the instrument that I really caught onto and then started touring with and spent the last 12 years of my life playing. So this is a sitar, but what you'll hear here is I built a circuit that I can tell what fret I'm on, and so I can drive a synthesizer from my sitar and then actually also play sitar. So I actually then went on and won a grant to go to Korea and do something similar and take traditional instruments there. What was awesome is that there's all these electronic parts there and you're able to get these things. This was years later, so a lot had advanced. Computers were smaller, the chips that you can put in were smaller, and the parts were more sophisticated. So these actually look way better than the instruments I actually play, which is kind of funny. But then working with artists who've never worked with this type of medium and who don't even speak English, but we can communicate with each other through music, and now they're using noise and all this control to actually interact with one of each other. So this is a little piece of this e-hagam. Sorry, if you don't like noise music, you probably hated that. So the other important part, putting sensors on instruments is really important to do the machine learning stuff I'm going to show you at the end. But also capturing what's going on the human body is very important. So I did this talk where I actually came on stage and controlled a number of robots by conducting. Okay, so how am I doing that? I'll show you in a second. That isn't a Connect. That would definitely not work. So I got really inspired by this Japanese artist named Tomie Han, who works with one of my good friends, also in my Garana. We went to Princeton together, and the husband and wife created this amazing character named Pika Pika. And it was amazing because she would have this technology on her hands, and she'd have speakers on her body, and she would walk around and control all these sounds. And later on, we ended up working with them and turned her into a lion. Okay, and that will make sense also soon. And what this is wearable technology. So I've spent a lot of time building and working on this. I first built one that was wired and had a 9-volt battery. then built something that was way too expensive for artists to use and only the medical students were allowed to use, and then finally was able to build something that was affordable and I could put on artists and my wife, who's also a dancer and unfortunately is going to be embarrassed in a second. So here's, again, we had these dancers actually controlling these moving parts. This is super quiet. And then went on to build with other students more complicated things than that actually use similar technology but to gesture the whole hand. Once a year, some student tries to do this. This one was really done well because they were able to study the Chinese music and actually go and actually do a PhD on this, where they actually had for 3 years recorded Chinese artists playing the Kuchin here and coming up with analysis. But we also were able to do real-time machine learning to figure out these dance gestures so that a dancer could control things on the stage, which is super cool. Okay, so now getting to I think the fun part, which is mechatronics. Again, another important part of the Gharana and what we teach. So first of all, I gave a talk a couple days ago, I think some of you were there, on mechatronic art and where that's going and some of my favorite artists. Some of you saw that, but there are a lot of incredible things, and every year as these parts become more and more available, we actually wait for the Silicon Valley to go out of business, and then we buy your recycled parts in these junkyards in LA and in San Francisco. So we love it when startups fail. And that's really the only way we can afford these things, and it's really important. If you don't know any of these artists and you were going to pick one, my favorite on this is Zamoon. So if you want to check that out, he's an incredible gallery artist. My journey here was, how do I get myself to interact with the first robot that I built, which is Mahadevibot. And so in this, you'll see my sitar, and I'm communicating with the robot with a lot of different algorithms and got it to actually perform only when I'm playing and use different arms based on what notes I'm playing. So you can see I was actually used to wear an accelerometer on my head, and I used to control different effects by moving my head all the way around. It was really probably damaging, but it was just a part of my performance. And now when I play acoustic sitar, I still find myself swaying my head, so there was some weird training going on. When I actually got to CalArts and got my faculty position, it was amazing because I found a community of artists in the faculty and students who were interested in the space, and we ended up together building all these instruments, which actually live in a classroom at the school. And each year we build a new instrument, and new composers come in and perform for them and compose for them. So I'll show you kind of that story. So this was the first one before I got there. You can see me building it, and they travel in suitcases, and that's how you tour with these things. This is one of and this now hangs above in a classroom. But then we ended up building this one, which was its friend, Ganapati bot. It kept getting taken apart and reassembled. Now it doesn't look like this at all, but these are the type of sounds you get. And then this gives you a preview of some of the other instruments that have been in the space. Again, some of them are already outdated and are now dead. But that's how things go in this field. But the coolest thing is, this drum set is very useful for a lot of the music that a lot of the students like to make. We also tried some other experiments of how do you make a drum that can go faster than a human. So the fastest drummer in Indian classical is this guy Zakir Hussain, which maybe some of you know. So we were trying to make this thing go. Do drum rolls. That was 2 arms of 12, so I think that can definitely go faster than a human. So that really helps explore this idea of what can you do with these instruments that you couldn't do if you didn't have this type of technology. And as we move forward on that, that becomes important. So you've seen a lot of drum things. We then also built a system for Indian classical melody, rag, and learning how to use that to teach different rag. And it's become very convenient because recently I have a child, and this is now how I'm going to teach him rag. So that's a morning rag, which is really cool. So writing software that figures out what the time of the day is and then plays the appropriate rag and then actually improvises and really learning that. What was amazing is I built that with a student, Jim Murphy, who went on to be a PhD in this subject, who's now a professor in New Zealand. And he learned so much from that project that he's now way better than me at this whole thing. And he built these crazy swivel instruments. And he started trying to attack different problems around expression where even on these drums you're seeing everyone strike in one place. He's now figuring out ways of making it more expressive and having the drums strike in multiple places on the drum. We've also built systems so that we can have lots of robots running at the same time. So this is the Novelist, and I'll show you a couple instruments we've built. But my favorite is when we take an audience space like this and put robotic things underneath your seats or around you so you're immersed in the sounds that we're actually creating on stage, really blurring and making more of an experience. So we do that building devices like this. This is my favorite implementation of it, which is the modulettes. So that talk I was doing where I was conducting, these were actually spread all around the audience, which was really cool. And they have little blue lights too, so you can see them making sound. Building big projects like this where you have instruments with a lot of different arms is, again, a very hard electrical problem, but now we have one solution that just does it. All right. And then doing projects like this. So this was a project at the school where someone donated a piano, and this wasn't even a class. Everyone just wanted to build this, so we just all started meeting and destroying this piano and turning it into this, and it's super gorgeous. And it's now become a big part of the classroom because it's everyone's favorite instrument because it makes lots of cool sounds. So these are some of the different instruments. This is another student who went on to make robotic speakers. So you can see them moving. She now has 8 of those, which is really cool. And this is one of my favorite students' work, who's also now a professor in New Zealand. He came from Iran and didn't even, know that he wanted to be an artist and was like, I studied physics, but I don't want to go into the military, and I play guitar kind of. And he's turned out to be one of the most incredible artists now. And check out this work. so we get that idea. So the key thing about technology is that you can get caught up in the technology and be like, wow, the technology is so cool and let me go do this thing. But you get like a one-trick pony and then you're stuck on stage and then you're like, okay, now what do I do? And that's a problem. And you'll see that in galleries too. There might be this one thing that's cool for like 1 minute and then you're like, now what? So the real thing is the art and the aesthetic aspect of what you're doing actually has to take precedence. Even if you have to simplify the technology, that is generally how you do a successful project. And storytelling and composition and all of those aspects have to take precedent. And that's a huge part of what we teach and how we move things forward. So again, leading by example, I ran an orchestra called the Machine Orchestra where I brought all these robotic instruments together and all these instruments that students were making, and we built this huge orchestra, and we have this network that we built, and everyone can communicate with each other and talk with the robots, and we can create this platform for composition. But in the end, what mattered was actually the piece and the show that we were able to put on. Here's a preview. So you saw a couple things here. So that was one of our biggest events we've done, but we're also working with lots of other Asian cultures. We do have Indonesian, Balinese education at CalArts, which was really awesome. And for one of the pieces that the professor went and wanted to play, we didn't have enough advanced players to play it. You needed 3. So we ended up building this machine that could play those 3 persons part. So this was really cool. And same when we went to Korea and we're building these instruments, passing on the knowledge that it doesn't matter if we made these instruments, we have to do a show, and there has to be a story, and we have to do something. So we came up with this concept, Rabbit in the Moon. This is just a preview of it. Again, bringing Indian and Korean culture together in different ways. So we were building all these things, and it was really interesting. And then at some point, I ended up getting married, and you've seen my wife in a couple of these things. And my wife's a Disney Imagineer. She worked in theater and dance, and she was like, man, you have this incredible technology. Why don't you use it for story? Why don't we take a story and build instruments and build all these things to really do something? So on our honeymoon, this is what we were doing. We started writing this story called Samsara, which we took the Panchtantra, which are these Buddhist stories. They're called the Jataka tales in Japan. And they're little fables about, like, you know, a monkey went into the forest and blah, 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 be vegetarian, you know, or whatever. You know, that's generally what the motto is. And don't kill people, something. So we took that concept. We took 5 different animals and their stories and their fables, and we had them reincarnate into each other. And again, the reincarnation was transferred through technology, which was cool, and we built technology for each one of these pieces. So now the story was driving everything that we were building, which was really cool and really true to the history of the school. incredible because, of course, Pixar has come from CalArts, and all of the ideas of film and story and all these things that happen there, we're now putting onto the stage. And to do this, you need a huge team. You need animation, you need choreography to tell story, you need lighting, you need production, you need writers. So it's much beyond the music school, which I was so used to working in. It's like, how do you build a production of this scale? So I'll show you some examples. So the animation director created these incredible pieces to tell the storyline. These were projection mapped onto the stage. There were 8 different projectors, which was pretty cool. And they would tell different parts of the story. There was a story about some mice, and this is where we first started building things for the audience. So we would put these things into the audience, and it felt like the mice, and they were composed properly, so these mice were scurrying around in the audience itself. So these characters were being built in the audience and on the projection screen. The bees, there was another story about a bee. I'll save the story part, but the idea was there was this character, and at some point these bees start flying all around. So we accomplished this by animating it, but then we built 12 huge robotic bees that lived above the audience and would start spinning, which you can see here. I'm not allowed to do this anymore, so this was a once-in-a-lifetime thing. And basically the story all came together, so you can kind of see it here. So I think the future of all of this is going to have to do with AI and machine learning, because even in that show, there were a couple hundred moving parts. To go through and program what each one of those were supposed to do during the 90 minutes of that show is not scalable. And with all these different things that we're learning with computers, as there's multiple computers are becoming part of installations and the creative practice, as people want to use 10 projectors, 20 projectors, and all these things, and you have to program each part. This can help the artist do what it wants to do, and there are now tools for those things to start happening. So I've been starting to work on this, and I'll give you a glimpse. Machine learning is really boring to talk about, so I'm going to try and not put you to sleep, but I just want to give you a vision of what this is. So where I started to learn this is I used to work with DJs a lot, and there used to be a beatboxer who wanted to beatbox and retrieve from their iTunes library what they were doing. So they wanted to do a beatbox, so they would actually query by using their mouth, and then it would go and retrieve from their library what they were doing. So again, this was a really easy use of machine learning back in the day. This is very simple to classify the difference between a right? And the beatboxer would decide what their gesture was or what their sound was to create that. So they would train a neural net and then do that. I did the same thing a lot with drums. So finding the difference on the Indian tabla about these different sounds, which we can barely hear, and then building a neural network around that and trying to have the computer with a microphone figure out what different type of sound and what different type of drum stroke you were making. And again, this would help with essentially automatic transcription of a type of music that has been completely ignored with technology. And I went on to actually have really cool ideas with a snare drum where you could actually have a performer strike in multiple different places on a drum and train a neural net to determine where the artist and the musician was striking on that drum, so that then you had a classifier that was telling you not only you were getting the sound, but this is actually where the instrument was actually being struck. With the sitar, which you have been seeing, I finally realized that the microphone's great for music, but you actually need all these sensors, which is what I was showing you, and taking that and doing analysis on not only the microphone, but the accelerometers, the pressure sensors, the different things I added to that instrument, so that I can do really advanced things like automatic transcription of a sitar player, which is freaking impossible and much closer now. As someone who wanted to play with robots, I needed to do beat detection. So I wanted to play, and I didn't want to have the robot control me. I wanted to control the robot, and how fast I was going is how fast the system would go. And building systems like this were important. Another huge thing is, what section am I in a composition? I don't want to press a button. I want the machine to understand that I am in this section. We have trained you before. You know I'm here. Turn the lights to the right place, put my presets correctly, and you know what you're supposed to do. And machine learning helps with those aspects. Moving in these type of ideas into education is really important. I imagine this place where a sitar player would sit down, pick up their sitar, and then automatically you're basically logged in to your system. So I did a lot of performer recognition to understand which performer was actually playing, which there's a lot there if you think about how is that even possible. This is the sensor. And Ravi Shankar and those famous artists obviously did not have this sensor. So what I was trying to do was build a neural net that would then use a microphone to train what that sensor was doing, so that then I could use all my other neural networks to actually do everything that I was doing with people who don't even have sensors on their sitar. That's a little bit insane. I did a lot of work with effective computing, working with motion capture to figure out the different types of affect, happy, sad, angry. This is also a very strange idea. And then started working with different students, specifically Jordan, on how you take this technology and build an automatic feedback system where someone's playing violin, you are getting automated feedback about how your different techniques are moving forward over a series of 16 weeks. And how do you automate that process? This turned into a lot of different things, which I'll show in a second. But there were a lot of cool things that we built for DJs as well. So imagine taking your entire iTunes library and then having it automatically set songs that are next to each other or songs that are similar to each other. And I'll show you an example of that here. So here's a multi-touch table where we built this, and you can see a DJ perusing their different samples. Here you see the similarity. I think that these self-organizing maps are the best way for people who've never seen machine learning in action actually see it happen, which is cool. I actually then went on to found a company that was about and is about arts education and giving it to the masses. And the problem we were having was thousands of people are submitting these assignments from all around the world. Can we use machine learning to automatically grade their art assignment, which could either be an image, a video, or a music file? So these are types of things that we built, like rule of thirds, placement and size. So automatically getting feedback, depth of field. So photography, that's great. For music, learning about sound design, getting a feedback on the different types of sounds that you've created, the idea in mixing, like how are you EQing, and getting visual and audio feedback behind that. And one of the craziest things was this idea of a comics class. So students are submitting these comics, and this was one of the most successful classes, and the idea was we needed to build an algorithm to sort all this and figure out what's going on. So here is a corpus of data from all these students who have submitted work. Okay, and this is a ton of data from 1 week of this work, and we used a very similar algorithm to what we were doing with that iTunes library, and we said, okay, use deep learning to actually determine and self-organize this so that artistic submissions can cluster together close to each other. And you can see here, I'm going to press a button in a second, and it will automatically self-organize. This is really scary because small startups, like art startups, can do things like that. Imagine startups with lots of money. So machine learning is something that is very real now, should probably be regulated, and really a big part of what's going to happen. And there are tools that are being built for artists. So what I'm really excited about is that Google has a group called Magenta, which is specifically about AI for the arts. And that's very exciting, and they are building tools, and we are very excited to see and be part of that conversation as that moves forward. So the last thing I want to say is, in this emerging field of art technology and all of these things, and with education, the most important thing that I have found is actually, as an artist, as a teacher, and even as a student, is actually being humble and actually realizing that there's so much that everyone has to learn. You have to become a lifelong learner. You have to set a good example for your students. You have to be at a point where you all are on the same playing field and you're trying to learn things together. And that's a really big part of succeeding as a digital artist in this field. So with that, I bid you namaste.